Hello, in this video we're going to be working with fractions, and as it says there, we're going to be converting between mixed numbers and improper fractions. Don't panic if you've no idea what those things are. You have seen them before, you probably just don't know they're called that. So we'll start with what is a mixed number. Well, a mixed number is anything that looks like that. So a whole number, the 3, the 2, the 4, the 3, the whole parts, and then afterwards a fraction as well. So what we call it a mixed number because it's a mix of a whole part and a fraction part. And you'll have seen them quite often. I mean, I guess the most obvious is when you say like 3.5, 2.5. I doubt you've said 3 4/7 very often, because we don't often work in sevenths in real life, because sevenths are a horrible fraction to work with. But certainly halves and quarters. I'm sure you've often said, you know, how long until something of 2.5 hours, or maybe an hour and 3/4. Okay, so mixed numbers, we use them all the time in day-to-day life. So what is an improper fraction? That's just the posh name for a top-heavy fraction, and you'll have worked with those definitely before, maybe even in primary school. Okay, so improper fractions really just means top-heavy, where you've got a bigger numerator on the top than you've got on the denominator on the bottom. And you can write any number as either a mixed number or an improper fraction. Okay, you've got a bit of a choice really, as long as it is improper. But you've got to be able to convert both ways between them. So you've got to be able to turn a mixed number into an improper fraction, and you've got to be able to turn an improper fraction into a mixed number. Converting between them is quite handy. For instance, you don't go into a shoe shop and ask for a size 11/2. 11/2 is the same as 5.5. Okay, so you've got to be aware of context. In maths, it's fine to work with top-heavy improper fractions, but in real life, we don't. Okay, so if we start with an improper fraction and changing it to a mixed number, and really the question you've got to ask yourself here is, what can you make with that amount of pieces? So, for instance, and you'll need to write these down, if I've got 9/4, now if it's 4 on the bottom, we call that quarters. Okay, so we've got 9/4, in other words. And now I'm saying, like, if you've got 9/4 and you put them together to try and make whole parts, what can you actually make? Go back to the old fraction favourite, which is pizzas, isn't it? If you've got 9/4 of pizza, how much pizza have you really got? So if we're working in quarters, it takes 4/4 to make a whole. So you don't have to draw it every time, but it helps to explain. So there's 4/4. Have I got enough to make another whole pizza? Yeah, of course I do, because I've got more quarters, haven't I? So how many quarters have we used so far? 8. All right, so 1, 2, 3, 4, 5, 6, 7, 8. What have we got left? We've just got that 9th quarter left. So in terms of a mixed number, what have we made? Well, we've made 2 whole pizzas, and we've got a quarter left. So 9/4 is the same as 2.25, because 8 of the quarters can make 2 wholes. If we have a look at another one, we'll go for 11/3. Now this time we're working in thirds. So I'm not going to be drawing the same as these, because if we're working in thirds, you only need 3 pieces to make a whole. So it looks a bit like the Mercedes badge when you're working in thirds. You must look at the denominator and make sure you're working in the right amounts. So we're in thirds this time. So 1, 2, 3 make a whole. Now I've got 11/3, so 11 of these pieces. Have I got enough to make another whole? Yes, because I can go 4, 5, 6. Do I have enough to make another one? Yes, because I can go 7, 8, 9. But do I have enough to make another whole? Not quite. I would need another 3, and I don't have 3 left over. I've only got 2. So all I can do with those last 2 pieces is put them into, well, as close as I can get to a circle. So 10 and 11. And what have we made? Well, we've made 3 holes. And what have we got spare left over? We've got 2 thirds. We're still working in thirds. This whole question in red has been in thirds, whereas when we were in blue, we were working in quarters. Okay, so the denominator won't change. You'll have some leftovers though. If it had been 12 over 3, I wouldn't need to make a mixed number because 12 over 3 would make exactly 4 pizzas. So 12 over 3 would just be 4. But because we're missing a third, if you like, we can make 3 and 2/3. If we do one more with drawings, and then we'll look at how to do it without drawing them anymore. So if we go for 17 over 5, so this now is fifths. And first of all, we've got to establish how many pieces make a whole. Well, if you're working in fifths, it takes 5. So this will be a tricky draw now. So 1, 2, 3, 4, 5. You'll have to forgive my not equal drawing skills. So 5 fifths make a whole. Can I do another whole if I've got 17? Yeah. So here's pieces 6, 7, 8, 9 and 10. Can I make another one? Yes. Okay, we've still got enough to make another whole one. So this is 11, 12, 13, 14 and 15. And then do I have enough to make another one? No, I would need 20 fifths. I've only got 17. I've used 15 of them. I've got 2 left. And so as a mixed number, 16, 17, I've got 3 holes. I've got 2 pieces left over. Last time I had 2/3 left. This time I've got 2 fifths left because the pieces I'm working in are fifths. Now, there is a quicker way than drawing. Obviously, we don't see mathematicians drawing shapes every time they've got to work with fractions. So, how do you do it? So, if we make a new one, we'll go for 18 over, let's pick something that's not going to work great. We'll go for 18 over 5. So first of all, you've got to work out how many holes you can make. Now remember, because we're working in fifths, it takes 5 pieces to make a whole. So how many times does 5 go into 18? 5 goes into 18 3 times. So I can make 3 whole pizzas. 3 times 5 is 15. If 3 times 5 is 15, how many remainders are there? 16, 17, 18. So there's 3 remainders. So it'd be 3 and 3/5. Okay. If I move that over, and we'll do another one then. If I have 22 thirds. So again, the question is, how many 3s are there in 22? How many holes can you make? So 3 goes into 22 7 times. So I can make 7 whole pizzas, if we're talking pizzas still. 7 3s, there were 21. So I'd have a leftover piece, and that leftover piece would be 1/3 because we started in thirds, so we're still in thirds. Okay, sometimes you see people accidentally swap their fractions to a wrong denominator, especially if you're working through an exercise that's got all different denominators, you get muddled up. Okay, so just make sure that your denominator hasn't changed. I'll do 1 or 2 more of these. So if we had 19 quarters, remember quarters is working in 4s. So how many 4s are in 19? Well, 4 4s are 16. So we can make 4 whole ones. If 4 4s are 16, we've got 3 remainders, 17, 18, 19. And we're working in quarters, so 4 and 3 quarters. And a bit of a bigger number now, then we'll have 37 eighths. So eighths is when it takes 8 pieces to make a whole. How many eighths are in 37? So 8, 16, 24, 32. So 4 whole ones, 4 eighths are 32. We've got 37, so there's 5 left over. It would be 5 eighths. So that's how you convert from an improper fraction to a mixed number? How many times does the denominator go into the numerator, and how many remainders are there? Okay, that's the quick way. Now then, if we want to swap the other way, so this is starting with a mixed number and going back to an improper fraction. Now the question is, how many pieces does it take to make that amount? So if I start with 3 1/4 this time, so this is my mixed number. Now this is important, we are working in quarters. So if I draw it, I've got 3 holes, 1, 2, 3, and a spare quarter. But how many quarters is that altogether? Now, because we're working in quarters, they get chopped into 4s. So 4, 8, 12, and the extra 1 makes 13. So it takes 13 quarters to make 3 1/4. If I do another one, I'll swap the colour. We'll have 2 4/5. Now this time we're working in fifths. So when I draw my 2 holes, I've got to cut them into 5 pieces this time. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's the 2 holes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we've got 4/5 as well. Now 4/5, I'll see how well I can draw this. There's the 4/5, not quite enough to make another hole, is there? Now we already had 10, so 11, 12, 13, 14. Altogether I've used 14/5. Okay, we went 5, 10, and another 4. I shouldn't really say 5 and then 10, I should say 5 add 4, shouldn't I? So is there a quick way of converting back again then? Well, yeah, you've got to pay attention to your denominator now. So if I say 4 2/3, you've got to realise that we're working in thirds. So 4 holes would be 4 lots of 3. So 4 times 3 is 12. So we've definitely got 12 plus the extra 2 makes 14 thirds. Okay, so it's 4 times 3 because we're working in thirds, and then add on the numerator as the spares at the end, the extra ones. So 4 times 3, add on the 2. We can do a few of these because they don't take very long. If we said 7 3/4, so this time look, it's 7 times 4 because every whole piece is made up of 4 parts, and we've got 7 whole pizzas. So 7 times 4 is 28, plus the 3/4 extra makes 31/4. And again, make sure that if you start in thirds, you end in thirds. If you start in quarters, you end in quarters. If we went for 3 2/7, this time we're working in sevenths. So I do 3 times 7. So 3 times 7 is 21, plus the other 2 makes 23 altogether, 23/7. And then one more then. We'll go for 4 5/8. So that's 4 whole pizzas, and each one is made of 8 parts. So 4 times 8 is 32. So we've used 32/8 to make the 4 whole ones, plus the 5 left over is 37/8 altogether. And that's how you convert from a mixed number to an improper fraction.